Okay, so this is number 56. In this problem, you'll explore the locus of points that satisfy an inequality. So once again, a locus of points is just a set of points that satisfy a condition. And here, part A, we want to represent the locus of points satisfying the inequality y is less than negative 3x minus 1 using a table of at least 10 values. So the first thing that we can do is set up our table, and we want at least 10 values, so I'm just going to come up with just 10 numbers here for my domain, my input. And I need some output values here that satisfy this inequality. So if I start with -1 and substitute that in, I would get 3 minus 1, or y is less than 2. So my range value here has to be less than 2. So you can pick any number less than 2 for your range value. So let's just say -4. That's less than 2. All right, let's go on to our next input. And we get y is less than 5. So with an input of -2, we need a number less than 5. So any number less than 5 will do. Let's just say -3. And we go on to the next one. Input -3. Output some value less than 8. We'll say 2. 2 is less than 8. And we go on to the next one here. And if we continue this, we can see a pattern developing here. So we have y is less than 2, y is less than 5, y is less than 8. So we can see that we have a pattern going up by 3s. So next we would have y is less than 11, y is less than 14. Okay, so let's do a number here, less than 11. Let's say -2. And let's say here -7 is less than 14. Okay, so we want y is less than, so 3 more is 17, 3 more is 20, so let's do those two. So for -6, we want a number less than 17, -2 is less than 17, for -7, less than 20, -7 is less than 20, and we've got 3 more, so up by 3s, y is less than 23, y is less than 26, and y is less than 29. So less than 23, -8. Less than 26, 9 is less than 26. Less than 29, 0 is. And so here is part A. We've represented the locus of points using a table. So my input and my output for that part. For the next part, it says, part B, graphical, represent the same locus of points using a graph. So for this next part, what we want to do is take our table, input, output, and graph these points. So for example, the first point, -1, -4, I would go left 1 and down 4. So left 1 and down 4, and I get this point here. Just a couple more examples. Left 2, down 3. So left 2, down 3 is here. left 3 up to, left 3 up to is here. And we would continue plotting all of those points. So that's part B. Part C says, describe the geometric figure that the points suggest. So, what we want to do is take a look at our graph, and we notice that all the points that we plotted are over here in this region, right here, and I'll get to this in just a second. So, they're bounded by some sort of line. So if we look at our inequality, y is less than negative 3x minus 1. So what we have here is a linear inequality in slope-intercept form. So in slope-intercept form, y equals mx plus b, where b is the y-intercept, that's where it crosses the y-axis, and our slope, the coefficient with the x, that is our rise over run. So if we wanted to graph this inequality right here, we would look at this number. So our slope is negative 3. Now we can express that as a fraction, as negative 3 over 1, or as 3 over negative 1, so that we have a rise and run. And then this number would be our y-intercept. So b is equal to negative 1. Now, if we take that back to our graph, to graph the inequality, we would start with our y-intercept. So we'd start here at negative 1 on the y-axis, and we can either go down 3 and to the right 1, or we can go up 3 and to the left 1. So from this point, up 3, left 1, up 3, left 1, or down 3, right 1, down 3, right 1, we get this line right here. Now, the reason why it is a dotted line is because our inequality doesn't say equal to. So we want all of the points not including the line. So we want a dotted line, and since it is less than, then it's going to be shaded below the line. That's why this is my sloppy shading, just showing that it's all of these points on this side. So for part C, we would say that it represents all points below and to the left of the line y equals negative 3x minus 1. And that's that.